So welcome, this is part 2 of the video topical based on integration from the past paper questions useful for both IBDP and A levels. So he gave the curve C is given by the equation x equals to 2t and y equals to t square. Find an equation of normal C at a point t equals to 3. So first what I have done it out, I have found it out dx upon dt, then I have found it out dy upon dt, then dy by dx is dy upon dt upon dx upon dt, which gives me t equals to 3. That is the slope of the tangent. But I want slope of the normal, negative 1 upon 3. Now I find the value of x, I find the value of y, so which gives me 6, 9. Then I use the equation y minus y1 equals to m times x minus x1, which will be giving me the equation of the normal. Next part, the normal meets the y-axis at B. The finite region R is bounded by the curve origin P and the lines OB and BP. Shade the region. So what am I going to do? So first of all, I'll find B. So the normal meets y-axis. Y-axis means x equals to 0. From there, I get y equals to 11. So the point B is 0, 11. Now, we know that x is 2t and y equals to t square. So x square equals to 4t square. So t square equals to nothing but what? Y. So y equals to x square upon 4. When I say y equals to x square upon 4, it's going to be a parabola passing through origin. So I draw a parabola passing through origin. Now there is a point 6, 9 and the normal at that point. I am drawing the normal at that point, and that normal meets the y-axis at B. Now shade the region. This point is P. This is going to be the answer, region R. Question number 19. Shown in the part of the curve y equals to e power 2x minus e power minus x. The shaded region is bounded by the curve x-axis and the line y equals to 1. Use calculus to find the region R in terms of e. So it is integral 0 to 1 e power 2x minus e power negative x dx. So 1 upon 2 e power 2x minus e power negative x upon negative 1 from 0 to 1. So 1 upon 2 e square plus e power negative 1 minus 1 upon 2 e power 0 plus e power 0. So it becomes 1 upon 2 e square plus 1 upon e minus 1 upon 2 and minus 1. So what am I going to take common? I'll take 1 upon 2 common. So e square plus 2 upon e and minus 3. That's going to be the answer. Question number 20. Given that 2y equals to x minus sine x cos x, show that dy by dx equal to sine square x. Hence find integral of sine square x. Use integration by parts to find integral of x sine square x. So 2 dy by dx equals to x derivative is 1, product rule, uv derivative is going to be nothing but what? Uv prime plus vu prime. So equals to sine x, and cos x derivative is negative sine x minus cos x, sine x derivative is cos x. So 1 plus sine square x minus cos square x. What is 1 minus cos square x? Sine square x. Sine square x plus sine square x. So 2 dy by dx equals to 2 sine square x. Then 2 cancels. So dy by dx equals to sine square x. So what I got? Dy by dx equals to sine square x. So what can I do? Dy equals to sine square x dx. Apply integral on both sides. Y equals to integral of sine square x. What was y? Y was x minus sine x cos x upon 2. So integral of sine square x is nothing but what? X minus sine x cos x whole divided by 2 plus c. Now use integration by parts to find integral of x sine square x. He's asking us to find it out. X sine square x. Integral of x sine square x dx. First function Integral of sine square x dx. What is integral of sine square x dx? X minus sine x cos x upon 2 minus integral of derivative of first function, integral of second function, x minus sine x cos x upon 2 dx. So what does that becomes now? X square upon 2 minus x sine x cos x upon 2 minus 1 upon 2 integral of x minus sine x cos x dx. So this becomes x square upon 2 minus x sine x cos x upon 2 minus 1 upon 2 x integral. X integral is x square upon 2 minus times minus is plus. Integral of this one is going to be sine x whole square upon 2 plus c. What is this one? Sine x whole square. How I got that one? I am going to use this formula. F of x times f prime x dx will become f of x whole square upon 2 plus c. So this is f of x and this is f prime x. It will become f of x whole to the power of 2 upon 2. So I derived that formula from basically this formula. F of x whole to the power of n times f prime x will become f of x whole to the power of n plus 1 upon n plus 1 plus c. Now question number 21. The rate in centimeter cube at which the oil is leaking from an engine sump at any time t seconds is proportional to the volume. So dV upon dt is proportional to minus V because it is leaking in a sump. At a time t equals to 0, V equals to A. By forming and integrating a differential equation, show that. So now dV by dt equals to minus kV. Take away that proportionality symbol and minus kV. Now 1 upon V, differential equation, so variable separable. 1 upon V dV equals to minus k dt. Then integral on both sides. So ln V equals to minus kt plus c. So V equals to e power minus kt plus c. So V equals to e power minus kt times e power c. E power c is some other constant. So a e power minus kt. He told that t equals to 0, V equals to a. So V equals to, we can do that, a equals to a times e power 0. So instead of taking as constant k over here, e power c is some other constant. We can take e power c equal to some other constant, maybe as b. So because he has already taken a, so therefore we can't take it as a. So b. So b equals to a. So what is my equation will become? V equals to b e power minus kt. So e power c is taken as some other constant b. So that way we cannot get in contradiction with the given constant. Now sketch the graph for the second part, B part. Sketch the graph of the relation V equals to T. Given that V equal to 1 upon 2a, T equals to T, show that Kt equals to ln 2. So for that, it is a decreasing e power minus Kt. It keeps on decreasing. This is A. V equals to a e power minus Kt. T 0 and V. Now he told that at t equals to capital T, V equals to 1 upon 2a. So 1 upon 2a equals to a e power minus Kt. So a gets cancels, apply ln on both sides. Ln 1 upon 2 equals to ln e power minus Kt. So minus ln 2 equals to ln e power minus Kt. So minus ln 2 equals to minus Kt, K capital T, Kt ln e is 1, minus minus cancels, ln 2 equals to Kt. That is what has been asked us to prove it out. Question number 22. Again, parametric equation is given. S is the normal. We have to find it out the equation of the normal. So first I'm going to find it out dx upon dt, which is 2 times of t plus 1. Then I'm going to find dy by dt, which is 3 upon 2 t square. Then I'm going to find dy by dx, which is dy by dt upon dx upon dt. So which is 3 upon 2 t square upon 2 times of t plus 1. So which becomes 3t square upon 4 times of t plus 1. Now t equals to 2. So plug in t equals to 2. 3 times of 2 square by 4 times of 2 plus 1. So that becomes 12 upon 12, which is 1. This is the gradient of the tangent. So the gradient of the normal will become negative 1. So now we have to find it out the values of x and y. So x will become 1 plus 2 plus 1 3 square 9, and y will become 1 upon 2 times 2 cube plus 3, which is nothing but what? 7. So the equation will be y minus y1 equals to m times x minus x1. So it becomes x plus y equals to 16. That is the equation of the normal. Next is asking use integration to show the area region R. So what should I be doing it out? Now I will be drawing a line over here, and this value of x, what was that value of x? X was 9. And this value of x, normal is meeting the x-axis. What was the normal? Y plus x equals to 16. So y equals to 0, x equals to 16. This value is 16. And this height is going to be 7. So area under the curve plus area of the triangle. Area under the curve from 1 to 9, y dx, plus area of the triangle. That's going to be the area of the shaded region. But it is in parametric form. Whenever it is in parametric form, this is going to be the area, y dx upon dt times dt. Then the limits also should be in terms of t. At 1, t was equals to 0. At 9, t was equals to 2. So in y, what is y? Y is 1 upon 2 t cube plus 3 times dx upon dt. What is dx upon dt? 2t plus 1 dt plus area of the triangle. Area of the triangle is half base into height. So what does that becomes now? Limits 0 to 2, 2 and 2 cancels, t power 4 plus t cube plus 6t plus 6 dt plus area of the triangle half times base is 7, height is also 7. So it becomes t power 5 upon 5 plus t power 4 upon 4 plus 6t square upon 2 plus 6t from 0 to 2 plus 49 upon 2. So 2 power 5 upon 5 plus 2 power 4 upon 4 plus 3 times 2 square plus 6 times 2 plus 49 upon 2. Simplify, directly I'm writing the answer 58.9. Question number 23. Again parametric form. The point A is intersection of C with the x-axis. Find in terms of A the x-coordinate of A. So x-axis means y equals to 0. So sine 2t equals to 0. So 2t equals to 0 means 0 to sine pi. Sine pi equals to 0. So what is t value? Pi by 2. So x equals to nothing but how much? T square. So x equals to pi upon 2 whole square. So what is the coordinate? Pi square upon 4 comma 0. Find dy by dx. So I find dx upon dt, which is 2t. Then I find dy upon dt, which is 2 cos 2t. So what will be dy by dx? Dy by dt upon dx upon dt. Dy by dt is 2 cos 2t upon 2t. So it becomes cos 2t upon t. Now gradient of the tangent will become cos of 2 times pi by, what was t value? Pi. At A. At A, t value is nothing but what? Pi by 2. 2 times pi by 2 divided by pi by 2, which becomes cos pi upon 2. Cos pi is -1 upon pi upon 2. So which is -2 upon pi. Now we have to know the values of x and y. So what was x and y? We got it out. Pi square upon 4 minus 0. So y minus y1 equals to m times x minus x1. So pi y equals to minus 2x plus 2 pi square upon 4. So 2 pi y plus 4x equals to pi square. This is going to be the equation. Then the shaded region is bounded by curve C and x-axis. Use calculus in terms of pi, the area of the shaded region. So anytime area equals to integral y dx is going to be the area. So the limits are t equals to 0 to t equals to pi by 2. Y is nothing but what? Sine 2t. And dx means dx. What is dx is going to be? Dx is going to be 2t. 2t dt. Dx is 2t dt. 2t dt. So it becomes 2t sine 2t dt, limit 0 to pi by 2. So again integration by parts. 2 first function, integral of second function, minus cos 2t upon 2 minus integral of derivative of first, integral of second, cos 2t upon 2 dt. So we can cancel it off 2, 2 and 2. So it becomes minus t cos 2t minus of minus plus cos 2t integral is sine 2t upon 2. Now the limits is 0 to pi by 2. Plug in pi by 2, negative pi by 2 cos pi plus sine pi by 2 minus 0 plus sine 0 by 2. So it's going to be minus pi by 2, cos pi is minus 1, sine pi by 2 is 0, 0, 0. So answer is going to be pi upon 2. Question number 24. Showing your method clearly in each case, find the integrals a, b, c, d. So the first one, integral of sine square x cos x dx. What am I going to do? Let u equals to sine x. So du by dx equals to sine x derivative is nothing but what? Cos x. So du equals to cos x dx. So it becomes u square du. So it becomes u cube upon 3 plus c, which is sine cube x upon 3 plus c. X ln x. X ln x. So first function is ln x, integral of second function x squared by 2 minus integral of, because first function is ln x, second function is x, because I use the acronym ILATE. Logarithmic is first function, algebraic is second function. So first function, integral of second function minus integral of derivative of first function minus integral of second function. Derivative of first function is 1 upon x. Integral of second function is x square upon 2. So x square ln x upon 2 minus 1 upon 2 x dx. So x square ln x upon 2 minus 1 upon 2 x square by 2 plus c. So the answer becomes, what does the answer becomes? X square ln x upon 2 minus x square upon 4 plus c. Finally, part C and D. Integral of x upon square root of x plus 1. Integral of x upon square root of x plus 1 dx. So whatever is under root equals to u square. That is the best substitution. So x derivative is 1. U square derivative is 2u du by dx. So dx is equals to 2u du and x equals to u square minus 1. So what does that becomes now? U square minus 1 upon square root of u square. Dx is nothing but what? 2u du. Then u and u cancels because square root of u square is u and u gets cancelled. So integral of 2 u square minus 1 du. 2 u cube by 3 minus u plus c. So again, what is u? Square root of x plus 1 whole cube by 3 minus square root of x plus 1 plus c. Now in part D, we are supposed to apply the limits for this one. So 2 upon 3 square root of x plus 1 whole cube minus 2 square root of x plus 1 from limits 0 to 3. Plug in 3. So 2 upon 3 or 2 upon 3 is for only for the first one. So 2 upon 3 square root of 3 plus 1 4 cube minus 2 square root of 3 plus 1 is 4 minus 2 upon 3 0 plus 1 is 1 cube minus 2 square root of 0 plus 1 is 1. So it becomes 2 upon 3 times 2 cube is 8 minus 4 minus 2 upon 3 plus 2. So it becomes 16 upon 3 minus 2 upon 3 is 14 upon 3. 14 upon 3 minus 2, which is 8 upon 3. So my final answer is 8 upon 3. Last question. Use a substitution to find the integral of this one and then solve the differential equation. So what is the substitution? U equals to 1 plus 2x square. So du by dx equals to 4x. So du equals to 4x dx. So integral of x times 1 plus 2x square whole to the power of 5 dx. So multiply and divide by 4. 1 upon 4. 4x dx is du and this is u power 5. What is u power 5 integral? U power 6 upon 6 times 1 upon 4 plus c. So it becomes 1 upon 24. 1 plus 2x square whole to the power of 6 plus c. Now solving the differential equation. dy by dx equals to x times 1 plus 2x square whole to the power of 5 cos square 2y. So 1 upon cos square 2y dy equals to x times 1 plus 2x square whole to the power of 5 dx. Then apply integral on both sides. Secant square 2y dy equals to integral of x times 1 plus 2x square whole to the power of 5 dx. Now this is from part 1. Secant square 2y integral is tan 2y upon 2 equals to, this is 1 upon 24 times 1 plus 2x square whole to the power of 6 plus c. But what are the values of y given? Y equals to pi upon 8 and x equals to 0. So this will become 1 upon 2 times tan 2 times pi by 8 is pi by 4 equals to 1 upon 24. 1 plus 0 whole to the power of 6 plus c. So 1 upon 2 tan pi by 4 is 1 equals to 1 upon 24 plus c. C equals to 1 upon 2 minus 1 upon 24. So c equals to 11 upon 24. So what will be the final equation? 1 upon 2 tan 2y equals to 1 upon 24, 1 plus 2x square whole to the power of 6 plus 11 upon 24. Multiply by 2, tan 2y equals to 1 upon 12, 1 plus 2x square whole to the power of 6 plus 11 upon 12. That's going to be the answer. So that completes the video. See you in the next video. Bye.